We're now moving on to calculate differences in time around the globe. You might have remembered me saying basically at the beginning of the chapter there are only 3 things that we look at: locating places, calculating distance between places, and now finally looking at time differences between places. Now, the difference in time depends on the longitude. And the way I've tried to explain that is by thinking about the sun shining directly. We've got the sun, and it's shining directly over this line of longitude. It means that it would be noon in this place. If the sun is directly overhead, it's 12 noon. And so you can see there I've written that when the sun shines directly over the meridian of longitude, whatever meridian it is, it's midday or it's noon. All the way along that northern hemisphere, equator, southern hemisphere, it's still midday. So we get to see that the line of longitude actually determines the time, because you would know that the line of longitude on this side of 120 east, let's say at 100 degrees east, is sometime in the morning. The earth hasn't rotated far enough yet. The sun's not directly over them. The sun is still in the east before midday. So here at 100 degrees east, it's in the morning. Whereas over here at something past 120, maybe 150, like Australia's at 150, if it's noon along this meridian, it's later in the afternoon for us. The sun's already past our meridian of longitude. Now, the other thing that we have to think about also is that this meridian also continues over. It's got a matching one around the other side. If it's noon over 120, its matching or opposite meridian would be experiencing midnight, 12 midnight. Now, we need to establish just how much time there is between, for example, any line of longitude. Say, let's stay with this 120 east, 120 degrees east, and maybe over here at 150 degree east, where we are. We know that on the east coast, we almost go through 150 degrees east. So if it was midday, if it was 12 noon, just here, all along the 120 degree east, just what time would it be in Australia, which has a difference of, you can see the difference has been 30 degrees longitude. So how much time does it take the sun to actually, or it's really for the earth to rotate through 30 degrees? So the sun stays fixed, the sun's not moving anywhere. It's actually the earth that's rotating. So how long does it take the earth to revolve through 30 degrees? We know that in 24 hours, the earth revolves through a full 360 degrees, because at one day, from noon one day to noon the next day, is 24 hours, and that's made a complete rotation of 360 degrees, the earth has. So if I was to divide both sides by 24, so you can see there 360 degrees, divide both of these sides by the 24 to get it down to in 1 hour In 1 hour, you can see that the Earth is going to rotate 15 degrees. It takes the Earth 1 hour to rotate 15 degrees. So for every 15 degrees difference in longitude, there is a 1 hour difference in time. So back to this example, if in Western Australia, along the longitude line of 120, it was noon, 30 degrees away is Sydney. 30 degrees means, according to this, double it, it means that it should be 2 hours later. And actually, those of you that have travelled from the east coast to the west coast would know that Sydney is 2 hours ahead of Perth and places in Western Australia. So the important thing is every 15 degrees longitude is equivalent to 1 hour time difference. So if we wanted to just know what 1 degree longitude was, then we would need to convert an hour to 60 minutes. 1 hour is 60 minutes. 15 degrees longitude down to, say, 1 single degree longitude. We're going to divide both sides by 15, and 60 divided by 15 is 4. So every 1 degree longitude change is 4 minutes time difference. Now, in reality, we don't obey this. I'll just look up the longitude, say, of Melbourne as opposed to Sydney, and I'll show you that we don't alter. We know that Sydney and Melbourne operate on exactly the same time, but let's have a look at what time difference there actually is according to the sun and our lines of longitude. So I looked up the difference in longitude between Melbourne and Sydney, and they're saying about approximately 6 degrees longitude difference, which would give approximately 24 minutes difference in time. However, we know that that doesn't happen. And the reason it doesn't happen is we put in place things called time zones, and we look at that in the very next exercise. Just so that we don't have the confusion that it is 6 a.m. in Sydney and at that same time it's 6:24 in Melbourne. That just is not going to work. So both Melbourne and Sydney operate on the same time. However, the sun is not directly over those two cities at the same time. Another thing you need to be aware of is this GMT, which stands for Greenwich Mean Time, and it's just referring to the time in Greenwich and comparing the time in other places compared to Greenwich. So to calculate time differences, it'll be necessary to know the difference in degrees longitude between places. For most of these questions, we're not going to consider time zones. We're just going to find the difference in longitude, like I would have here between Sydney and Melbourne, and then I would have said, well, the difference in time should be 24 minutes.